Welcome back to my channel. This is the continuation of course, the topic finding the domain and range of the different circular functions. This time, we will be getting the domain and range of the tangent, the cotangent, the secant, and the cosecant functions. Let's do it. The domain of tangent and secant will be the set of real numbers minus n pi plus 2hb divided by 2b, where n is an odd integer. Take note that you have to express first the given in the form of y equals a tangent b quantity theta minus h plus k. And for the secant, we have a secant b quantity theta minus h plus k. So their domain will be this one. The domain of this two will be this one. Now, what about the domain of the cotangent and the cosecant? The domain of the cotangent and cosecant will be r minus n theta plus hb over b, where n is an integer. This one is, of course, a set. Remember that we can only find this if and only if your y is already expressed in a cotangent b quantity theta minus h plus k, and y equals a cosecant b quantity theta minus h plus k. Now, the range of y equals a tangent b theta minus h plus k and cotangent. Take note this time that we have cotangent and tangent. So, the range of the tangent and cotangent function will be, of course, the set of real numbers. Why? Such that y is the set of real numbers. For the secant and the cosecant function, the range will be negative infinity, comma, k minus the absolute value of a, union, of course, k plus the absolute value of a, comma, infinity, positive. Number 1, y equals 2 tangent theta plus 1. We need to rewrite it this way. So this is y is equal to 2 tangent of 1 times theta minus 0 plus 1. Theta minus 0 is theta times 1 is theta. So therefore that is 2 tangent theta plus 1. So for us to be able to identify the a, you have to write it this way. A, and then B, and then H, and then K. So our A here is 2, our B is 1, our H is of course 0, and our K is 1. Okay. So to find the domain, it says here that the domain will be the set of real numbers minus the set of n pi plus 2 times h is of course 0, times b1, divided by 2 times b1. So this is, n is an odd number or odd integer. Okay. So this is now D, our domain is the set of real numbers minus n pi, this is 0 over 2, where n is an odd number or odd integer. Okay, so this one is our domain. Take note that the angle is not defined, therefore we cannot identify this n. Okay. For the range, it says here that the range of the tangent is the set of real numbers. So therefore, y, such that y is any element in the set of real numbers. Example number 2, we have y equals negative 3 cosecant of 2 theta plus pi over 2. Okay. So it is already written in this form. So therefore, we can identify now the A, the B, the H, and the K. So our A here is negative 3. Our B here is positive 2. And our H here, this is written in, of course, minus. So this one is plus. So therefore, this one is negative pi over 2. And our K is a known 0. To find the domain, it says here, the domain of will be this one. So we have, the domain will be the set of real numbers minus n pi plus hb, h is negative pi over 2 times 2 divided by b, which is 2, where of course n is an integer. Okay. Again, the angle is not defined. It's not given. So therefore, we'll just simplify it. The domain, therefore, will be the set of real numbers minus n pi minus pi, because we can cancel it, over 2. So this one is n is an integer. Okay. So this one is your domain. For our range, we have to look for cosecant. Where is cosecant? This one is the cosecant. The cosecant will be, the range of the cosecant will be the set of all y such that, of course, this one is negative infinity, comma, k. Our k is 0 minus a, the absolute value of a. Okay, the absolute value of a. And then union, this one is k. Our k is 0 plus the absolute value of negative 3, comma, positive infinity. Okay. So if we'll simplify it, this one is negative infinity, comma, this is negative 3. Okay, union, we have 3, because absolute value of negative 3 is 3, comma, positive infinity. Okay, so therefore this one is y such that y is less than or equal to, greater than or equal to, rather. This one is 3 and infinity, so therefore greater than or equal to 3. And this one is less than or equal to negative 3.